Can you hear me?
Hey, how's it going?
Hey.
Okay, you can hear me. Let's test my headphones. Can you hear me now?
I can hear you now.
Oh, awesome, awesome. All right, cool. So I think some more people joining, right?
I think so.
George. Yeah, okay. I'll prepare a little bit. So when we start recording, after that, I'm gonna submit. I'm probably gonna submit this talk to RailsConf, but I'm sure they're not gonna accept it. Just for the heck of it.
Sweet, dude.
Here, techlunch now. Okay, and let me share my screen. What do you think happened to everybody else?
I don't know. It was a little weird.
I think Josh said, I'll be there.
Oh, sorry.
Hmm. Johnson is typing. Hmm. 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 Hmm.
Johnson's mad at you, Michael.
Yeah, yeah, I see, I see. Because he was sleeping and then apparently it woke him up. My message woke him up. Do you want to do it just for you or just maybe move it? Hello?
Are you talking
Oh,
to?
oh, I see. So many people came. All right. Are you guys there?
I'm
Or
here.
just you're here, but the other guys they
Yeah,
just
I'm
came in?
here.
Okay, everybody's here. Are you ready? You ready?
Sure.
Okay. Let's start. So I want to share my experience scaling Rails app from uh, in at Sonar, and so basically uh, we grew from zero to about 5,000 requests per minute, and we experienced a lot of scaling troubles, like request timeouts for multiple like various reasons, starting from like slow database queries to running out of memory. And I will share my experience scaling our app. The stack is of our app is Rails and Sidekick and Redis and Elasticsearch and Node.js and React, Coffee, Puma, Heroku, and Amazon RDS. Does it sound familiar? Hopefully yes. All right. So first of all, we always measure things. Uh, we measure our app performance using different tools like a benchmark or New Relic. New Relic is really awesome because you can sort, as you see on the right, there's a screenshot from New Relic. You can sort actually thread that may be a web thread or just a normal thread or like workers by the time consumption or like highest through output. And you can see which is the bottleneck of your app and then go and optimize it. So we have like several strategies for optimize. I mean, I wrote several strategies for optimizing the things. First is the database may be inefficient, right? Uh, so I update query. We're going to talk more about it. And then also, if you want to make something really fast, we just cache it. Or if something takes too long, like for example, image processing or uh, some other huge queries or like export features, we add as async workers who will do the job and then update the front end through polling or WebSockets. And then the best way to optimize it, in our opinion, is remove extra code. No code, no trouble. Okay, the database. Generally, if if you use SQLite, it's pretty fast on data manipulations. If you set indexes right. Uh, but there is a downside. If there's a lot of indexes, it will consume a lot of memory. That's how we ran out of memory. Our database became slow because after it grew to like a huge database, we still had a lot of space, but we didn't have enough RAM on the database, and that's why it would use disk space, and it would be slow as like really slow. Um, We sometimes we use explain for BigQueries to see how uh, how it's being processed um, on the in production. Also, we measure indexes in memory to see like which indexes we don't need and how to optimize them. So we have like a visual image of like a snapshot of our database kind of thing. So we can understand the structure of the database better. Also, it may be Rails, but sometimes executing the request to the database is faster than using standard Rails models because it takes a lot of time to build these models after the database request is complete. Because all this Rails, it has like a lot of they have a lot of methods and stuff, and sometimes it's being slow. Then sometimes it's good to just use cache to temporarily keep objects and not using too much database. For example, API calls. There's like a lot of various API validations that we had that we just cached. So API is really fast, especially those API calls that are being called a lot of times. And well, we keep an eye on DB configuration, and we also use a slave database uh, to for things such analytics where small log is not very important, but it's read-only and it doesn't block the main database. There is also a thing that more Rails related, but I put it here too. So when we basically use findage, find in batches and update all, not to read the whole database kind of records into Rails memory because it also make a lot of trouble. Yeah. Also, there is a special slide for SQL explain. Maybe you used it before. If you have like a strange like Rails query just like this, and you want to see how it's going to work in production, you can always run explain. That will give you some cost, and you can compare this cost to like other queries, and so you can optimize it and see how you're optimizing it. This is a screenshot. So if you basically type in your query in Rails and then say .explain, which is SQL thing, you will get the explanation. Mhm. Then measuring indexes. In Postgres, it's very easy to measure indexes just like this. And if you just if you execute this line, it will give you the list of uh, tables and indexes in them and how much they um, weight. We recently moved to Heroku RDS because they have a lot of memory, they're cheaper, and Heroku is very inconvenient to upgrade. Each time you upgrade Heroku database, you have to copy it, you have to create a new database and copy the data over a new database, and there's always downtime. But RDS, you can just dynamically update, adding some CPUs and dynamically adding memory, RAM and stuff. We also did it with no downtime by scaling down Sidekick workers and having Bob still running. So a lot of tasks would create a worker that won't be executed until we migrated. Basically, it took us 20 minutes and some delays, but no downtime. Everything was there. Cache. Uh, well, cache makes it super fast, and Redis is so you can calculate from this formula that Redis is 2 bazillion times faster than the database. Uh, and yeah, there is a downside using Rails that it's kind of expensive. You can keep anything, but the best thing about Redis is the data is expireable, so you can set an expiration on anything in Redis. So basically, you don't have to keep in Redis like old messages, as we are a messaging company. You don't have to keep old messages in Redis. They'll just get expired. But for the new messages, where the user usually click over and the data that user interacts with, it can be cached, and with cache, it's really fast to do for the user. interacting with all UI. So examples of what we cache in Redis. If you don't know what our app is similar to Facebook Messenger, how it looks. It enables businesses to send messages to communicate with their customers through different mobile channels like Facebook, text messages, and other channels. And for example, we keep last 20 messages per customer and the list of customers who messaged you recently. Also, we cache things in local storage. Like, for example, we cache list of users of the current company just in local storage and drafts of your messages that you are going to send. So here is a small video how it works when it's cached. So if you look at the video, I'm not sure if you can see the video, but if you can't, I'll just tell you it's fast as like really fast. Yeah, caching makes it fast. Okay, DevOps. Uh, Maybe you know what Edge 14 is. It's just running out of memory, and we used to have a lot of that. For example, uh, just with the time, your Puma workers take more and more times and go bigger and bigger and grow until they just explode. So it's really good to kill Puma workers time to time, and we have a Puma worker killer that kills uh, uh, workers asynchronously. So we have like several Puma workers, and it kills each worker time by time, so they not kill at the same time. That would cause some downtime. Uh, so that helps not to run out of memory. Also, it was very important to set up the right type of Heroku dynos that have enough memory to run your app, and then make your app eating less memory is important too. So just keep an eye of Heroku configuration, and there is actually a memory usage graph that you can see in Heroku. And now, as you see, it's pretty sleek. But it used to be like on the it would go to the top line and just go over memory, over 2 gigs, and crash the whole app. So we used to have like our app crashing once a day, twice a day. Also deployment. We use deployment with no downtime, and Heroku supports it. They have a feature called pre-boot. It restarts Bob asynchronously after deploy has been complete. So it would restart Bob servers asynchronously, like one by one, not all at the same time. So users won't actually notice the deployment. The only thing is you have to be careful with the migrations, because if you push something, migrations will run first, but then the web servers will restart later. So we usually deploy a version of the code that supports 2 versions of the database, and then run migrations, and then remove the old code. When I say run migrations, means yeah, run migrations. So we deploy a version of code, and then deploy the migration, and then deploy a new deployment which removes the code. Ruby. So important to keep the Ruby up to date, have the latest Ruby, because garbage collector significantly improved, and just latest Ruby is so much faster. Some people ask me, hey Michael, what garbage collector is? And the answer is like young developers write a lot of garbage code, and it's some device that collect all this garbage code and put it to trash bin. Yeah, I'm just kidding. Uh, write Ruby code that uses less memory. Uh, so you know how you say map and stuff for database records. It's better not to do it. Just pick only records that important to you from the database, so you don't like have it all in memory. And you can use plug sometimes. Also use modify things in place. Modifying things in place uses less memory, because if you say kittens equals map cats.map, it will keep cats in the database and kittens. So it will be twice. Your memory basically will have two copies of that object. Rails. Um, so I noticed that views may be really slow. Even JBuilder is slow, so we used the JSON serializer on the objects. Uh, Let me see. I need it because I'm like low. But try to see. There is one. There is my charger right there. Uh, so we used JSON serializer that actually saved us maybe 100 milliseconds for like heavy calls, 50 to 100 milliseconds, maybe even more for heavy calls. Also, sometimes we just avoid. I just avoided using active record, and for like calls that with the high throughput, uh, it's actually improved the performance. Uh, because there are some heavy objects. Yeah, and this is the heavy part of Rails is um, it fetches the database, but then it uh, it it's gonna create all these methods, heavy objects with methods based on the database records. Um, then using preloading is pretty good in Rails. Uh, Loading models you actually need. Use in instead of like map kind of thing. Or instead of like users where ID is 5 or where ID is 6 or where ID is 7, using kin is so much better. And this is probably, you already know it, independent delete all as opposed to dependent destroy. Destroy will cause all callbacks, and delete all just delete all. So if you need to have callbacks, use destroy, but if you not, delete all is so much better. This is a new relic of our app, and as you see, it's pretty fast. It's 80 milliseconds, um, and the slowest part is this blue ocean. It looks like a beach, right? This is yellow database, and then the ocean of Ruby. Ruby is the slowest part in our app. You see, it takes like maybe 60-70%. And last time in the class, I benchmarked active record base connection as opposed to like some object dot find. So I execute the same query but in a different way, and this actually was faster. So we could see benchmark. Probably I'll paste a screenshot to this presentation about it. Also, there's in DevOps. I forgot to mention that there are formulas that calculate how many servers you need based on this response time, and uh, we uh, we calculate the amount of dynos just to keep the speed of response time like about this fast. So if it goes higher, we just add more servers. And sometimes we change configuration dynamically when we have like a heavy day with everybody sending billions of messages to everybody. Then we add power, we add verb, we add workers, so it works faster. Okay, async. We use Sidekick for queues, and it's very important because it distributes work over time, and it helps to a user not to wait until some tasks are completed in their web calls. After the job is complete, we use WebSockets or polling to update the UI. For example, we use it for data export, image processing, and third-party APIs or some analytics queries that we use. Yeah, and because of RPMs vary during the day, it really helps to keep the app running really well, having workers just doing job like evenly. We increase the amount of workers when the usage is high, the RPMs high. Test and report. So a really good thing is writing test. It's really fun to have tests because otherwise we had cases where we didn't have a test for something and it would break production, and it's not nice, or it would cause just downtime because of production data would match like developing data. uh, and stuff like that. Um, we have integration tests and acceptance tests and benchmark tests. And we really like using Circle CI because we can just run tests asynchronously in the cloud. And air break, and if you have an error, we immediately are notified. We have some extra data, some extra uh, info too. We used Elasticsearch, and Elasticsearch is actually pretty cool. It makes it so fast to uh, search, and yeah, we updated using a worker. If you change anything, a worker being created that updates Elasticsearch. Then uh, Typhus, whatever this is pronounced, gem is faster than REST client, so it's faster for API calls and stuff. And high Redis is Redis compiled in C, so it's faster. And then also Stack Overflow was really always useful. And in conclusion, is Ruby is a little slow, but you can go pretty far. A bottleneck can be also other things like database. And bad code is no good. Hopefully it was new for you. And then kittens always help. Thank you. That's it. Do you have any questions?
Do you have any experience using AWS rather than Heroku?
Uh, so
Dealt with
for
that at all?
for AWS, uh, we didn't merge our app to AWS, but we use RDS,
Right.
and we also use Redshift. We're gonna use Redshift for logs, and RDS is a pretty good experience. I like it a lot.
That makes
But
sense. I definitely like New Relic for Heroku
yeah,
apps, but I haven't really found anything equivalent for AWS. I
oh
think we're
really?
about to start really like kind of hitting these scaling issues in the next months to come in the ACAC projects.
Oh okay. I
Probably be
think
coming back to your presentation. So,
yeah. I'll send it to you. Uh, Yeah, we also use Redshift for logs, and it was pretty fun. We thought about using CloudWatch, but instead just Redshift is like a huge, it's
mm,
super cheap, and you can query your logs. It's awesome.
nice.
And you should migrate to RDS as soon as possible because the later you upgrade, the more data you're gonna have, so the slower the migration is gonna be
Mm,
because it's downtime.
true. Yeah, we're using RDS now, so
Oh, awesome, awesome.
pretty well. Got a little bit of Redis too. There's some like
Yeah.
automated workers, but I definitely see what you mean with like the big database queries. Like we're doing a couple of those. That,
Yeah, when the data is huge, like
yeah,
when the app was built, when the database was small, like now we have tens of millions of like records of
wow.
different types, and sometimes if you say a wrong query, it may be pretty long.
Mm. Do you have like a staging server that you do load testing on?
We do load testing in development.
Okay.
We do have staging, but we don't like do load tests on staging.
Mm.
But on my database on my machine is like 15 gigs,
Okay.
and it's a migrate of like all production database and some generated data, and we do benchmark tests just on my local machine, which is not like very like precise because the server is so much faster, but it helps to compare like how slow it is, how fast it is. We have like benchmark tests written. Uh,
Yes.
any other questions? I see I see Brad has his eyes closed. No.
I just have two screens. Did you look into any like just normal like view caching? And did that help at all? Or
You know what? We don't cache the whole view, and it's kind of already cached because we have a one-page app and all assets are cached, right? So it's already kind of cached the view. And what we have is just API call, and we don't cache the whole call, the whole entire call, um, but we have a lot of just things cached, like a lot of things cached. Just if you do API calls, half of them are cached, For example, the customer information is cached unless you change it. But if it's not cached, it will cache it like if you access it within expiration. So if you do calls on the customers that were updated like recently, they're still in cache. But if you like try to catch a customer who was like updated a long time ago, it's probably not cached. It will read the database, but it will cache it right after. So yeah, we use caching like this with expiration because customers tend to use the latest stuff more often than old stuff. It's like on Facebook. You never, if you have like a your ex back in the bottom of like Facebook messages, you never like open it, right? But you always like message your buddies that are on the top of the list in your Facebook messages. So the same concept applicable for our app. So no more questions? Nice. That was pretty fast. Cool.
Thanks a lot.
Oh, good. Yeah, thanks, man.
Really
That was super
fun.
useful.
Thank you so much, and let me know if you need access to the slides and if you have some feedback.
Thanks. That was great.
See you at RailsConf.
Yeah, maybe I submit the other one, the video that of the Rails class. But yeah, cool. Thank you so much.
Well, thanks a lot. Talk to you
Yep.
later.
All right.